Okay, I'm going to talk about the energy of the future that I think is the fusion energy. So, first of all, I'm gonna try to explain to you the difference between the two main nuclear reactions, which are fusion and fission. As you might tell by the names, fission is when you have a large atom and it splits into two smaller ones, while fusion is the opposite. You have two small atoms and they join together to form a bigger one. Okay, so simple. Now, modern nuclear reactors work by fusion reactions. They have the uranium-235 atoms, and they heat them with a proton, which is the small blue circle on top, and that causes the fission reaction to start. So the uranium atom splits into two smaller atoms, liberating energy and three other protons that can cause other chain reactions. So how this works is this energy is used to boil up some water, and this water is turned into steam, and the steam is used to power up a turbine that generates the electricity. So nuclear energy work by this chart. It may seem a little complicated, but actually it's pretty simple. You have energy on the y-axis and molar mass on the x-axis. So according to this, you will have fission when you go to the left and fusion when you go to the right. So nuclear reactions start right here in the uranium-235. When they have the fission reaction, they go this way, which means there is this little slope that will generate the energy. So basically this is why the energy is created. Now fusion reactors will work the other way around. You have two small atoms, which are two hydrogen atoms, and they join to form a helium atom. This also releases energy because if you take a look at the chart again, you see that hydrogen is right here. And when they join, they go this way, they go up to form the helium atom. So this also creates energy, as you may see, it creates a bigger amount of energy. So what I want to talk to you about is what the advantages will be of this fusion energy. First of all, it has an abundant fuel supply. This means that the fuel is easy to obtain. Hydrogen is a really common element, and it's not like uranium that it's a little bit harder. It is safe because it has very few risk of an accident. It's also clean because it produces very little nuclear waste in comparison to normal nuclear energy, and it generates a lot of energy. So by this point you might be wondering, why the hell haven't we done this, right? Because it seems like it's the perfect energy. Well, it also has some disadvantages. First of all, it's a grand scientific challenge to fuse two hydrogen nuclei to create helium. And it's also an unproven type of energy because it's still on the research phase. It's also very expensive to create this, and this is because it requires extremely high temperatures, more or less of 100 million degrees Celsius. So this is because these are the type of reactions that happen on the sun and around stars. So to recreate these reactions here on Earth, we will need a lot of energy. So this is still a prototype energy, but there is a project going on. It's called the International Thermonuclear Experimental Reactor, or ITER. It's been built up in France, and it is expected to start functioning by 2025. So this reactor has been made to prove the viability of this type of energy and see if it really is as good as it seems to be. Because we have solar, we have wind, we have hydraulic energy, but this type of energy will generate a ton more energy than those types, and while also having very few contaminants. So we will see how this turns out in 5 years, and I hope you enjoy my presentation. Here are my references too, and thank you very much.